Good day, everyone. Welcome again to Basic Calculus. So now we are done with the determining the limit of the function. So through looking at the table of values or by looking at the graph of the function y is equal to f of x. Now we will apply the limit theorem in order to hasten the steps to identify the limit of the function. We will consider c as a constant and f and g are functions which may or may not have c in their domains. Under the theorem number 1, the limit of the constant is the constant itself. If k is a constant, then the limit of k as x approaches c is the constant itself. Example, the limit of 2 as x approaches 2 to c. So since 2 is a constant here, so the limit is 2. B, limit of negative 3.14 as x approaches c. So since negative 3.14 is a constant, then the limit of that function is the constant or the negative 3.14. The limit of 789 as x approaches 500 is also 789 regardless whatever the value of c here, as long as the function is a constant, the limit of that function is the constant itself. Number 2, the limit of x as x approaches c is equal to c. This is also thought as the substitution law because we simply put x as to be substituted by c. So the limit of x as x approaches c is equal to c. Example, the limit of x as x approaches c, we will just substitute the value of c to our x here, so the limit is equal to 9. For letter B, limit of x as x approaches 0.005 is equal to 0.005. So letter C, limit of x as x approaches negative 10, of course, is negative 10 as well. For the succeeding theorems, we will assume that the limits of f and g both exist as x approaches c and that they are L and M respectively. So the limit of f of x as x approaches c, let's label it as L, and the limit of g of x as x approaches c, let's label it as M. Okay, for the constant multiple theorem, this theorem states that the limit of a multiple of a function is simply that multiple of the limit of the function. So example, the limit of k times f of x as x approaches c. So we will just separate the value of a constant times the limit of that function. So k times limit of f of x as x approaches c. We know that earlier that's equal to L. So the constant times the limit of the function is the true limit of that function according to the constant multiple theorem. Example, if limit of f of x as x approaches c is equal to 4, so we will find the limit of 8 times f of x as x approaches c. Since 8 is a constant, so we will just separate it 8 times the limit of f of x as x approaches c, which is given here, equals 4. So 8 times 4, that's 32. Another one, limit of negative 11 times f of x as x approaches c. So since negative 11 is a constant, we will just separate it. So negative 11 times the limit of the function. So our given here, that's equal to 4. So negative 11 times 4 is equal to negative 44. So another one, limit of 3 halves times f of x as x approaches c. So 3 halves is a constant, so we will just separate it times the limit of the function, which is given here, 4. So 3 halves times 4 is equal to 6. Okay, so the addition or subtraction theorem. This says that the limit of a sum of functions is the sum of the limit of the individual functions. Subtraction is also included in this law. That is, the limit of a difference of functions is the difference of their limit. So that's the limit of f of x plus g of x as x approaches c is equal to the limit of individual functions L plus m. Or in the case for subtraction, that's limit of f of x as x approaches c minus limit of of g of x as x approaches c, or L minus m. So let's have an example here. Example, our given is limit of f of x as x approaches c is equal to 4, and the limit of g of x as x approaches c is equal to negative 5. Then we will find limit of f of x plus g of x as x approaches c. So we will just find the individual limit. So the limit of f of x as x approaches c plus limit of g of x as x approaches c, which are given here. For f of x, that's 4, and for g of x, that's negative 5. So 4 plus negative 5 is equal to negative 1. Same goes here in our subtraction theorem. So we will just subtract the limit of f of x minus g of x as x approaches c. We will just subtract the individual function. So the limit of f of x as x approaches c, that's 4, minus the limit of g of x as x approaches c, that's negative 5. So 4 minus negative 5 is equal to positive 9. The multiplication theorem. So the limit of a product of functions is equal to the product of their limits. So it's the same with the addition subtraction theorem. Ang ilahang kalainan lang is the multiplication sign. So the limit of f of x times g of x as x approaches c is, we will just find the individual limits and multiply it. So that's L times m. Okay, another example here, same given previously. So the limit of f of x as x approaches c is equal to 4, while limit of g of x as x approaches c is equal to negative 5. So using this one, limit of f of x times g of x as x approaches c, we'll just find the individual limit. That's 4. And for this one is negative 5. We will multiply it. 4 times negative 5 is equal to negative 20. So for the division theorem, so the limit of a quotient of functions is equal to the quotient of the limits of the individual functions, provided the denominator limit is not equal to 0. So individual functions, the limit of f of x over g of x as x approaches c is equal to the individual limit of the function. So limit of f of x as x approaches c over limit of g of x as x approaches c. So that's L over m, where our m here must not equal to 0. So example, our given are this one. Limit of f of x as x approaches c is equal to 4, and the limit of g of x as x approaches c is negative 5. So that's the limit of f of x over g of x as x approaches c. So for numerator, that's 4, while the denominator is negative 5. So the answer is negative 4 over 5. Another example, our given here is the f of x as x approaches c is equal to 0, while the limit of g of x as x approaches c is equal to negative 5. So we'll just put the individual functions in the numerator and the denominator, which is 0 and negative 5. So 0 divide negative 5 is equal to 0. Next is the power theorem. So this theorem states that the limit of an integer power p of the function is just that the power of the limit of that function. So the limit of f of x raised to p as x approaches c is limit of f of x as x approaches c raised to p, or that's the limit raised to p. Example that given here, limit of f of x as x approaches c is equal to 4. So looking for the limit of f of x raised to 3 as x approaches c. So the given here, limit of f of x as x approaches c is equal to 4. So 4 cubed is equal to 64. Another one, limit of f of x as x approaches c is equal to 4 again. So the limit of f of x raised to negative 2 as x approaches c. So the given here, limit of f of x as x approaches c is equal to 4. 4 is to negative 2. So the answer is 1 over 4 squared, which is equal to 1 over 16. Lastly, the radical or root theorem. So this theorem states that if n is